BOOBAWAMBA is a level that has been gaining a lot of attention lately for many reasons, like how dark the level is, the ending, the 5 objects, and the fact it was raised to number 3 on the demon list, just to name a few. So today we will be doing a deep dive into the many secrets of BOOBAWAMBA and what does the level really mean. If we want to know everything about BOOBAWAMBA, we first need to ask ourselves, what does BOOBAWAMBA even mean? To explain this, I've brought in my nerdy counterpart, Joe. Take it away. Hello, everybody. It is I, Joe, and today I have brought to you BOOBAWAMBA, an explanation video. Many of you may ask, and probably have asked, what is a BOOBAWAMBA? It sounds like absolute nonsense, which a lot of levels that Agunakun name are just complete nonsense. So, essentially, a BOOBAWAMBA is a Googleism. And that means it's a large number in the field of Googology, the study of large numbers. Googology, if you couldn't already tell, is named after the number Google, which is 10 to 100, which is a pretty famous large number. So, it's a pretty big number. But how big, you may ask? Well, let's examine. A BOOBAWAMBA is equal to this. Now, you may be asking yourself, what does any of this mean? And you are right to be asking that, because you probably don't know what the fuck this means unless you already know a fuck ton about Googology. So, to get up to where we need to be, to understand what any of this actually means, we're going to have to start off at the basics. Exponents. A to the B equals A times A times A, B times. We've all learned it in high school. It's a pretty simple concept. So if we order this in, like, say, I don't fucking know, this order. First, repeated succession is just, which is just adding 1, is addition. You add A to B is taking A and adding 1 to it B times, which we may think, oh, addition's the fundamental. Nah, that's succession. Just adding 1. It doesn't get more simple than that. Second, repeated addition is multiplication. You add up A, B times, you get A times B. It's something we learn in grade school. Third, repeated multiplication is exponentiation. It's something we learn in high school. It's this. What they don't teach us, however, is fourth. What is repeated exponentiation? That thing is called tetration. It is named after 4 because it's the 4th thing. Very creative, I know. But I'm going to use this notation because it's how I can easily write it in Notepad. So A tetrated to B is A to the power A to A to A to A, B times. It creates a sort of power tower. For example, if we take 3 tetrated to 4, it's 3 to the 3 to 3 to the 3. Now, if you do that, it would be 3 to the 27. But 3 to 27 is 7.6 trillion and something. And then 3 to the power of that ends up being a 3.6 trillion digit number. So even with, like, very, very small numbers, you get really, really big, really quick. So it can grow insanely fast. But is there anything beyond that? Well, obviously there is. It's Googology. It deals with big numbers. To understand what we do next, we need to understand Knuth up arrow notation. Now, in the previous one, I was already kind of using it with the 2 up arrows. 3 up arrows. So for example, 3 up arrows, it's called pentation, but it's easier in general just to say triple up arrow. It's the most simple to understand, and it works like it, and I'll call this double up arrow for the time being. So A triple up arrow B is A double up arrow B, or double up arrow A, double up arrow A, all the way, and you have BAs. For example, 3 triple up 3 is 3 double up 3 double up 3. Now, that means 3 double up 7.6 trillion And if you learned from before, that is 3 double up, 3 double up, 3 double up, 3 double up. And there's 7.6 trillion threes. It's incomprehensible. It's absurd how big these things get. Now, we can make a generalization of Knuth up arrows, because the rule for them is that A, double up anything, or like any up arrow number 1 is A, regardless of the number of arrows. Now, if we're not dealing with 1 or that, we'd have the generalized case A, n up arrows B. This would end up being A, n minus 1 up arrows, A, and n up arrows B minus 1. This is the simplest way to write it, because if you expand that, that just ends up being A, n minus 1 up arrows, n minus 1 up arrows, A, blah, blah, blah. And you do have BAs. So, if you write out this first step, it goes all the way down until it equals 1, and then it just equals A. So, I will usually write out this step as well to show what the logical steps are to bringing it down to more manageable numbers, which we will need heavily in a little bit. But as you can easily see, like, adding the things below it and all the time, it gets really messy. But at least it's easy to understand. But there has to be a way to write it cleaner. So what we're going to do is we're going to go beyond Knuth up arrows, and we're going to go to something called operator notation. Operator notation, if you take something A, C up arrows, B, A, bracket C, B. It's very simple. A bracket 1B is equal to A up arrow B, or A to the B. A C1, A bracket C1 is equal to A. A bracket CB is equal to A bracket C minus 1 of A bracket C B minus 1. So that would end up being A, C minus 1, C minus 1, C minus 1, B times. It's what we saw before with n minus 1 up arrows each time, but this is much cleaner. We can also take this a step further. A double bracket 1, B, ends up being A, bracket A, bracket A, bracket A, bracket A, bracket A, all inside this, with B, A's going from here, not including these. It's just not. It's including from this A to this A, that's B A's. So inside you got A up arrows, A. Then if you go one step outside, it's A, up arrows, A, up arrows, A. So I think you can understand that, but it's a bit fucked up as well. So for example, 3 double bracket 1, 3 ends up being 3 double bracket, 3 double bracket, 3 bracket 3, 3, inside brackets. So, that means this inside is 3 up arrow 3. That means 3 up arrow 3. It's, yeah, 3 up arrow 3 minus 1. And this is the amount of up arrows. And then 3 up arrow 3 minus 1, 3. This is like fully expanded, not just anything, so it might look weird, but don't worry. So yeah, it's absurd. It's really, really big, really quick. So what about A double bracket 2 of B? That means A double bracket 1A, double bracket 1A, double bracket 1A, double bracket 1A, double bracket 1A. I probably should write parentheses around it, but honestly, I just kind of forgot to, and I don't care enough right now. So yeah, you have BAs all separated with these double bracket 1s. And if you saw what double bracket 1 can do, it's pretty big. In general, A double bracket C, B is A double bracket C minus 1, A double bracket C minus 1, blah, 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 blah. And you keep doing it, double bracket C minus 1 of A, and you end up having BAs. Brings you, what is triple bracket 1? Now, with triple brackets, it's basically the same thing. Triple bracket 1 means double bracket A, double bracket A, double bracket A, double bracket A, and that be A's from in this range here. It's important to do that because if you can, it's always going to be an odd number of A's if you go with everything. You can't control it sometimes. You can't control it at all. It just happens. But that ends up being BAs. So, in general, A, n bracket 1, B equals A, n minus 1 bracket, A, n minus 1 bracket, B times up to the middle. It's very, very ugly, very, very quick, as you can see. Like, A, n bracket C is A, n bracket C minus 1, A bracket, n bracket C minus 1, with n brackets each time of B. So again, it gets really, really messy. But, again, how can you make it cleaner? There obviously has to be some way we can organize this to make it a very, very tasteful function and system that you can do to it. Well, we're going to talk about array notation. Now, you need some base terms for this. The base is the first entry, which I'll typically denote with A. The prime is the second entry. I'll typically denote it with B. The pilot is the first non-1 entry after the base and prime. You'll understand that in a minute. So, we're going to start off with linear arrays. It may sound weird, but bear with me. For instance, we're going to now, we don't want to confuse this with the operator notation, since this is a completely different notation entirely. It's not operator, this is array notation. Bracket A is just A. That's how it's always going to be, and this is how it works. Bracket A comma B is equal to A to the power of B. Bracket A comma 1 is equal to A, is equal to bracket A is equal to A. I will probably stop saying brackets unless it's like I need to. But so for size, so that's size 2. Size 3, we're deal with 3 inputs. So A, comma 1, comma C. Now the thing you need to understand is if the prime is 1, the answer is always A, regardless. If the last input is 1, you chop it off. So A, B, 1 is equal to A, B, A to the power of B. In general, if you have A, B, C, it's equal to A, comma, bracket, A, B minus 1, C, close bracket, comma, C minus 1. This means if you take it another step further, it's A, comma, bracket, A, B minus 2, C, close bracket, comma, C minus 1, close bracket, comma, C minus 1, close bracket. You do this enough times, you get A, comma, bracket, A, comma, bracket, A, comma, bracket, A, blah, 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 to A, comma, bracket, A, comma, C minus 1, close bracket, blah, 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 comma, bracket, C minus 1, comma, bracket, C minus 1. And you have B sets of brackets. That's what it is. And if this looks familiar to you, it's because that A, B, C is equal to A, bracket C, B. If this 3 input size is the exact same thing. Now, if you go to size 4, you may be asking, are size 4 arrays the same thing as using n brackets in operator notation? And the answer is yes, it's exactly that. As always, if you go to the first case, the prime is 1, A. Always. If you go here, the last input's 1, cut it off, it's A, B, C. If you go here, there's 2 1s, cut them off, A, B. Simple. Now, we're going to deal with A, B, 1, D. Now, you may be thinking, oh, just cut these off. No. In fact, it said the pilot is the first non-1 entry, which in this case would be D. What you'd end up doing, in this case, is you end up taking this whole thing, and you'd be placing it inside all of this. Here, you'd take down by 1, you'd reduce the pilot by 1, and then you'd replace all the first inputs with A. Now, this may look weird, but it'll make more sense when we get to more sizes, higher sizes of this. In general, expanding this all out would be bracket AA, comma, bracket AA, comma, bracket AA, blah, 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 comma, bracket AAA, D minus 1, bracket, comma, D minus 1, bracket, comma, D minus 1, blah, 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 all the way down. And you'd have B sets of brackets. So, it just ends up being that. The next thing is generally A, B, C, D. Now, A, B, C, D ends up being A, comma, replace B, the prime, with A, B minus, with the same, but you reduce B by 1, and then afterwards you reduce the pilot by 1. Now, you're asking, why isn't that the pilot? No, the pilot is the first non-1 entry, which in this case is C. C is reduced by 1, and B is reduced by 1, but it's also replaced with the function itself. This ends up being A, comma, bracket B, or A, comma, bracket A, comma, bracket A, comma, bracket A, comma, bracket A, blah, blah, blah. And you get to A, comma, C minus 1, comma, D. And then close bracket C minus 1, close bracket C minus 1, or close bracket C minus 1, D, close bracket C minus 1, D, close bracket C minus 1, and with, again, B sets. And this does end up being exactly A, comma, B, comma, C, comma, D is equal to A, D brackets C of B. Now, if we go to size 5, we don't have a reference for what this ends up creating. So we have to fully rely on the arrays. We can't rely on other notations because as the sizes go up, they just become useless. And plus, you'd have to go to like 2-dimensional space in order to map out what this is without just making an absolute mess. So we're going to have to fully rely on the arrays here. So for a 5-argument thing, if the prime is 1, it's A. Since all of these last inputs are 1, you cut them all off. A, B. Since the last 2, A, B, C. Since the last one, it's A, B, C, D. Again, pretty simple concept to understand. Now, you have A, comma, B, comma, 1, comma, 1, comma, E. Since E is the pilot, since it's the first non-1 entry, what you end up doing is you're going to replace the last 1 with the function itself, and then you're going to replace all the inputs before it with A. You'd end up being with A, comma, B minus 1, 1, 1, E, comma, close bracket, comma, E minus 1. In general, this would end up being bracket A, comma, close bracket, open bracket, A, bracket, A, blah, 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 blah. You do B sets of brackets, A, comma, E minus 1, close bracket, E minus 1, E minus 1. Again, you always reduce the pilot, and you always reduce the prime and the pilot until you get to a place where the original prime goes down to a form like this, because in all essence, this number right here ends up becoming, when B reaches 1, this just becomes A because of this rule. And all similar rules before as well. This just becomes A. It's not anything extraordinary. It's just once the prime reaches 1, you just have to change it to A, and at the end of it, you'll just have the pilot, which is reduced all. A, comma, B, 1, A, B, 1, D, E. Again, you'd replace the 1 with the function itself, and replace all previous inputs with A. So, you'd have A, comma, bracket, A, B minus 1, 1, D, E, comma, D minus 1, D's the pilot now, first number after 1, D minus 1, E. Again, it's A, bracket, A, bracket, A, blah, 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 blah. with B brackets. You have A, comma, A, comma, A, comma, D minus 1, E. Then close bracket, D minus 1, E, close bracket, D minus 1, E, blah, 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 blah. It's a very, very tedious process with large numbers, and it just becomes the same thing over and over again. Now, with the, and as you can probably assume, if you take the argument A, B, C, D, E, that means this would be A, comma, and replace the prime this time with the function itself, and reduce the prime by 1. Afterwards, reduce the pilot by 1, since C is the pilot, which would end up being A, comma, A, comma, A, comma, A, B times A, comma, A, comma, C minus 1, comma, D, comma, E, close bracket, C minus 1, D, E, close bracket, C minus 1, D, E, close minus 1, all the way down. That's what this ends up being. In general, A, comma, 1, yada, 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 stop it, N, always equals A. A, comma, B, comma, C, all the way up to N, comma, 1, and this could be any number of 1s. It will lop them off, it stops at N. Now, here's the fun part, and this is where it becomes a very interesting process to work through. A, comma, B, comma, 1, comma, 1, comma, 1, and we'll just say M 1s. You have M amount of 1s, comma, C, comma, D, blah, 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 up to N. The only thing we really care about are these. Since C is the pilot is this time. So, this would end up being M plus 1 A's, comma, A, comma, B minus 1, M 1s, comma, C, comma, D, all the way up to N, comma, C minus 1, comma, D, all the way up to N. That's the first step. This just ends up being M plus 1 A's, M plus 1 A's, bracket M plus 1 A's, M plus 1 A's, M plus 1 A's, blah, 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 up to C minus 1, and then all the way up to N, bracket all the way up to N, close bracket all the way up to N, with C minus 1, then all the way up to N, and it's the same thing. You always reduce the prime and the pilot until the prime is gone. And you replace all the last one with the function, and make all the numbers before it A. It's a lot. It becomes very big, very fast, and impossible to work with very early on. And in general, if you have A, B, C, D, blah, 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 all the way to N, you get A, replace prime with the function, reduce the prime by 1, close bracket, reduce the pilot by 1, go all the way back to N, and you just get A, comma, C minus 1, comma, D, all the way up to N, close bracket, C minus 1, D, all the way up to N, da, 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 you get, B sets of brackets. Now, I'm just going to go over some basic shortcuts really quick. A, comma, 2, comma, 1, comma, 2 equals A. A, comma, 3, comma, 1, comma, 2 equals A, comma, bracket, A, comma, A, close bracket. With 4, it's A, comma, A, the prime, A, comma, bracket, A, comma, bracket, A, comma, A, close bracket, close bracket. If you replace the prime with 5, it's A, comma, bracket, A, bracket, A, bracket, A, A, close bracket, close bracket, close bracket. Add another A in there somewhere. It doesn't really matter. You get the point. If you go 5 arguments here, A, comma, 2, comma, 1, comma, 1, comma, 2, this ends up being 4 A's. You replace with 3, it's because A, bracket, A. 4, A, bracket, A, bracket, A, close bracket, close bracket. With 5, it's with A, 2, 1, 1, 1, 2, ends up being A. If you replace the prime with 3, it's A. Yeah, and just keep going, and then just for shits and giggles, we'll do one more. A to 1, 1, 1, 1, 2 is A. This ends up just being the thing. Now, if we go back here, scales and number comparison. the fact of the matter is, when you're dealing with something like this, just looking at it, you don't really understand the scale of how big these numbers get. So, it just becomes complicated and procedural. So, we're going to use some comparisons and a couple evaluations to see where this leads us and how this ends up comparing to large numbers. For instance, Graham's number. Graham's number is the largest number that is used in a mathematical proof, and honestly, I don't know if it still is, but at the time of its creation, it was the largest number ever used in a mathematical proof. So, we're going to go all the way back with 3 operator bracket 4, 3. This ends up being 3 quadruple up arrow 3, which ends up being 3 triple up arrow, 3 triple up arrow 3. Which, if you want to get it all out, ends up being 3 triple up arrow, or double up arrow, 3 double up arrow, double up arrow, double up arrow, double up arrow, 3 double arrow 3. And you do this 3 triple up arrow 3 times. The problem, and if you go back, this was already, like, incomprehensibly big. Even at, like, very, very small values, this ballooned into an enormous size that is barely computable. Not really, I just made this shit up, but, like, you get the point. It's fucking big. We'll just call this G1. Now, if we G1, then obviously it must be a G2. G2 is equal to 3 bracket G1, 3. That means it is 3 with G1 up arrows. You remember how big G1 was? 3 quadruple up arrow 3. This is massive. It's so big, I can't even start to wrap my head around it. But that's the number of arrows. That's not the number there. That's not how many times you do something with it. No, that's the arrows. And then what about G3? Well, it's 3, G2, 3. Obviously, we're getting into some pretty ridiculous territory. In general, G of n is 3 bracket G of n minus 1, 3. So what is Graham's number? G64 is Graham's number. You use it 64 times to where it's 3 G63 up arrows 3 of 3. Or 3. Whatever. I already said 3. Now, if we take this comparison with the array notation given, Graham's number is not even close to 365, 1, 2. If you expand this out a little bit, you get 365, 1, 2 is equal to 3, 3, 364, 1, 2. This ends up being 3, 3, bracket 3, 3, 3, all the way down to 3, 3, 3. This ends up being with 65 entries. Now you may be wondering, 65? Wait, why 65? It's because this ends up just being the start of our G1 estimate, which it's really not. We'd have 3 triple up arrow 3 instead of this, which would be much smaller, but at the same time, if you understand this up to this point, you should probably be fine. So, like, you may be asking, oh, but 65, that's not too big, that's not too bad. What about, like, just all small numbers for all the arguments, like, just all 3s? Well, you have to replace the prime with the function itself, reduce it by 1, reduce the pilot by 1. Again, you got a 1 here, reduce it down to 3. Now you put it back in, you got down, you reduce this down to 1. Now you put it in again, reduce down to 1, replace it with 3. Now you take this, put it into here, reduce it by 1, and then you do it again, reduce by 1. Oh, that's prime's 1, reduce it to 3. You do it again, down to 3, bam. It's 1, reduced down to 3. Now you take it again, and bam, you reduce it down to 3. Now it's 3, 1. You do it down here, and you got it down to 3, but that's the end of it. So then you have 3, 3, 3. This is 3, 3, 3, this is 3, 3, 3 triple up arrow 3, because we already figured out that's what that was. So that means inside all of this, this ends up being 3, comma, this massive number, 3 with 3 triple up arrow 3 up arrows in between it. And that's the prime. It's 3, comma, this, comma, 1, comma, 2. And as I wrote here, if I tried to do the next step, I would die. It's stuff like this, where it just keeps increasing and increasing and increasing and increasing to a point where we don't even know what would happen by the end of this. Probably the heat death of the universe would come before we're even a quadrillionth of a percent into this. Even way more than that. It's like, go for like so long, wouldn't even be able to compare. This is how big this stuff gets. And that's with 4 3s. So, of course, we need to go a step forward. Multi-dimensional arrays. Yeah, we go from linear to multi-dimensional, because of course we do. Now, I won't go fully in-depth into this, because we just need the basics of this to understand the size of the BOOBAWAMBA. The first thing I'm going to introduce you to is B and A. This AND is a function that operates onto A's, which says that it's an array of A, comma, A, comma, A, blah, 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 with B A's. Now, I'm going to introduce you to something a little different, but this, while I get rid of the notation really quick, if you want to understand more about Googology in general, understanding this is honestly pretty helpful. So A, comma, B, close bracket, with underscore 1, so this would be in the subscript. I just use underscore because notepad, yay, equals A, comma, B. It's nothing too hard to understand there. A, comma, B, close bracket, subscript 2 ends up being B and A. In general, so the notation we're going to replace it with is, instead of putting it in the subscript, we're going to replace that with parentheses 1n. It may be hard to understand what you're going to do here, but in all essence, it's a very similar thing, and I'll get into this example here. But, so, if, so in general, you have m entries of something, the, comma, or parentheses 1n, that just means A up to M, subscript N. So, same thing, A, comma, B, parentheses 1, 2, ends up being this, which is B and A, which is this. So, what do you do with, like, more than, like, and always understand that once you get down to 2 entries, then you can change it into something. That's pretty important to understand when you're working with the parentheses, because it could get ugly really fast if you don't do that. You have to get all the way down to there before you can even try to do something with it. So for instance, A, B, C, D, parentheses 1, 2. This is A, comma, bracket, A, B minus 1, C, D, parentheses 1, 2, comma, close bracket, comma, C minus 1, D, parentheses 1, 2. Again, you take the prime and replace it with the function, reduce the prime by 1, and reduce the pilot outside of it by 1. But the important thing to understand here is that the parentheses 1, 2 is not part of this. It is acted upon this function as a whole, so you have to derecurse the function all the way down to 2 inputs. That's the important thing to understand. With that, we're going to work with a small example. 3, 3, 3, 1, 2. Parentheses 1, 2. Which is 3, 3, 2, 3, parentheses 1, 2, 2, parentheses 1, 2. So I'm not going to go through all that because that would take a billion years. But, so what I'm going to do is I'm going to take the function, I'm going to plug it into the prime here, since that's the thing we need to evaluate. I'm going to plug it into the prime, reduce it by 1, reduce the pilot. reduce the pilot by 1, which is, in this case, 3 here. Oh, wait, the prime's 1. We can change this all down to 3. So it just becomes 3, 3, 2, parentheses 1, 2. Now this is the function. Place the prime with it, reduce the prime by 1, reduce the pilot by 1. Now the important thing to understand is since that this is not part of the function, that means when this becomes 1, you can just get rid of it, because that's essentially the same thing as having 2 inputs and then 1 right after it. Now, alright, so we gotta evaluate this again. So you take this, plug it in, that ends up being 1. Oh, that's 1 in the prime slot. That means you can make this 3. Oh, we have 2 inputs now. Great. So that means we're going to take the prime and say that's how many of the base you're going to get. So 3, 3, 3. It's 3 3s. Nothing too scary, right? Okay, that's just 3, triple up arrow 3. Big, but as you can see, it can get a lot bigger. So that would be 3, 3, triple up 3, 1, 2. I don't know why I had another thing there, but who cares? We'll go with it. I'll just get rid of it. So, it's b times this. That means you have, and this is not the whole function. This is just the prime of this part here. Ends up being 3, 3, 3, 3, 3. How many 3s? 3 triple up arrow 3 3s. And this is not even close to the end of the function. So, yeah, no, this is absurd. Using the subscript or the parentheses 1, the results you get are basically unimaginable. Like, these numbers are so fucking big. It's insane. So, what are we going to do now? We're going to be one step away from the BOOBAWAMBA. The Booble. I know, funny name. It's like Google, but you replace these two, the G's with B's. That's it. The Booble is equal to 10, 10, 100, parentheses 1, 2. If you take that, you replace the function, reduce the prime, reduce the pilot, 10, this, you take it again, replace it, reduce by 1, take, replace by 1, and quickly you can see, it's going to take a long time before we're even able to get the 100 down to 1, able to cut it off, and then we're going to deal with a massive number that's just operating on 10, which is 10, insanity, and that's just going to be nearly impossible to deal with. And then that means you have the parentheses 1 in here. You also have it out here. And you also have it here. And you also have it here. And you're also going to have it so many times. The thing with this function is that it gets massive. And so with that, we are ready to see the BOOBAWAMBA. The BOOBAWAMBA is equal to 10, 10, 100, parentheses 1, 2, and 10. That means it's 10, 10, 10, 10, 10, 10, 10, 10, blah, 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 blah. The amount of 10s you have is a booble. That's how many 10s you have in this. And to say that this number is fucking gigantic would be the understatement of the millennium, dude. This is how big a BOOBAWAMBA is. If you wanted to know what the hell is the name of that, what the hell is the name? BOOBAWAMBA, what does that even mean? It's this. The BOOBAWAMBA is this giant fucking number. It is absurd. If you want to learn more about Googology in general, you can go to the Googology Wiki fandom. It's an awesome place to just scroll and just waste time. I did it a lot in high school, and I I have never got caught for it, so awesome. But yeah, that's about it. So thank you for listening to me yap about the name of a GD level for a while. But for any of you who wanted to know, what the hell does this mean? This is it. The BOOBAWAMBA is a giant fucking number. And with that, I will end there. Thank you.